The gyroscope was filmed falling with the camera placed sideways so as to capture as much of the movement as possible. A large ruler was stick to the wall so I could get the calibration data for the calibration stick. The calibration stick was set to 10 centimeters, approximately 4 inches. The coordinate axis was aligned so that the gyroscope moved along the minus y-axis from the origin. 27 frames were used to track the motion, placing the marker on the expected center of mass. In some frames, the gyroscope image was blurry and the center of mass had to be roughly estimated. .45 seconds of movement was tracked, corresponding to a fall of approximately 99 centimeters. From the graph of y versus t, it can be seen that the position does not change proportionally with time. And at the same time intervals, the observed y position is increasing in absolute values. Alright, now let's see how does this model behave. Alright, so here we have the weight represented by the green vector, the gyroscope here, and this is the trajectory. Now we proceed to the analysis of the data, the collected data and the predicted data from the model in the spreadsheet. So here at blue we have the observed positions, and in red we have the predicted positions from our model. There seems to be good agreement between the experimental data and the model, except here at the middle. In this case I think that this is related to the fact that the camera was filming the gyroscope falling at a certain angle, and that this must be a parallax error. So to summarize, in this model we used as the net force only the weight, that is the gravitation. The drag force was not used in this model, and there seems to be good agreement between the experimental and the model. So what does it mean? As I said, the experimental data and the model data seem to fit well, except here where there is a slight discrepancy. So this was assuming that there was no drag force. Now, what if there was drag force? If I introduce drag force here, increasing the proportionality constant, now let's see what will happen. So there is no apparent change. Let's see in the spreadsheet what does this mean. So with this drag force, here is the plot that we get. So there seems to be a bit of adjustment at the beginning, but then there is a bigger discrepancy at the end. As to the question, what if the object was initially thrown down? Let's see in my model implementation. here in the gyro velocity, the initial velocity, I have placed the y-axis -1 meter per second, so there is an initial velocity as if the gyroscope was thrown downwards. Let's run this model to check what would happen. Alright, so in this case the predicted position would be lower and the speed would be greater if the object was thrown